Alright, so in this problem, I have 99 to the power of x plus 9 is equal to 9,999 to the power of x plus 9. So to solve this, I'm going to first start by using the property of exponents that says a to the power of n plus n is equal to a to the power of m times a to the power of n. So by using this property, 99 to the power of x plus 9, that's going to equal 99 to the power of x times 99 to the power of 9. And 9,999 to the power of x plus 9, that's going to equal 9,999 to the power of x times 9,999 to the power of 9. Now I'm going to divide both sides by 99 to the power of 9 times 9,999 to the power of x. So then these two cancel out for my left-hand side, and these two cancel out for my right-hand side. So now I have 99 to the power of x over 9,999 to the power of x is equal to 9,999 to the power of 9 over 99 to the power of 9. Now this is the same thing as 99 over 9,999 to the power of x, which is equal to 9,999 over 99 to the power of 9. And now this simplifies to 1 over 101 to the power of x is equal to 101 to the power of 9. And this is the same thing as 101 to the power of negative x is equal to 101 to the power of 9, meaning that negative x is equal to 9 and x is equal to negative 9. So now to check, I have 99 to the power of x plus 9 is equal to 9,999 to the power of x plus 9. We know that x is negative 9, so now I have 99 to the power of 0 is equal to 9,999 to the power of 0. Anything to the power of 0 is 1, so I have 1 is equal to 1. And this is right, so I know my solution is right. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 130. So to solve this, I'm going to first start by rewriting 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 130. And I can actually switch the places of 3 and x. So this is the same thing as 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 130. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 130. Now I'm going to subtract 130 on both sides. These two cancel out. So now I have y to the power of 3 plus y minus 130 is equal to 0. Now I'm going to rewrite y here as negative 25y plus 26y. Now I have this minus 130 is equal to 0. And now y to the power of 3 minus 25y, the greatest common factor is y. So I get y times y squared minus 25 plus 26 y minus 130, the greatest common factor is 26, so I get 26 times y minus 5 is equal to 0. And y squared minus 25, that's the same thing as y plus 5 times y minus 5. And now if I factor out y minus 5, I get y minus 5 times y plus 5 plus 26 is equal to 0. So now this gives me two equations. I have y minus 5 is equal to 0, which means y equals 5, and I have y squared plus 5y plus 26 is equal to 0. And to solve this, we actually have to use the quadratic formula, and I'm not going to waste your guys' time by doing it, but if you do end up doing it, it actually won't work because you get the square root of a negative number, and you can't take the square root of a negative number. So we are left with y equals 5, and remember how we let 2 to the power of x equal to y. So this means that 2 to the power of x is equal to 5. And I'm going to take the log on both sides to solve this, so I have log 2 to the power of x is equal to log 5. And if I have something in the form log a to the power of b, I can move this exponent to the front, so it's going to equal b times log a. So this is the same thing as x times log 2 is equal to log 5, meaning x is equal to log 5 over log 2. Alright, so in this problem, I have 2 to the power of x is equal to 3 to the power of x. So I obviously want to find the value of x here. So for my solution, I'm going to first start by writing 2 to the power of x is equal to 3 to the power of x. And I'm going to take the log of base 2 on both sides. So now I have log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. Now, if I have something in the form log base a of a, this is simply equal to 1. So as you see here, we have log base 2 of 2. And actually before I cancel these two out, if I have something in the form log base a of to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have x as my exponent, so I can move this to the front. So now I have x times log base 2 of 2 is equal to, I'm going to do the same thing over here, log base 2 of 3 to the power of x. I can move x to the front here. So now I have this is equal to x times log base 2 of 3. Now remember, if I have something in the form log base a of a, this is equal to 1. So log base 2 of 2, these two cancel out, so I get simply left with x times 1 is equal to x times log base 2 of 3. And x times 1 is simply x, so I get x is equal to x times log base 2 of 3. Now, I'm going to subtract both sides by x log base 2 of 3. So these two cancel out. I get x minus x times log base 2 of 3 is equal to 0. Now if I factor out x, I get x times 1 minus log base 2 of 3 is equal to 0. And if I divide both sides by 1 minus log base 2 of 3, these two cancel out, and I'm left with x is equal to 0.
Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 9 to the power of 2x minus 1 minus 9 to the power of 2x minus 2 equals 1944. So what I'm first going to do is I'm going to rewrite 9 to the power of 2x minus 1 as 9 to the power of 2x minus 2 times 9 to the power of 1. Because remember, when we're multiplying these, we would add the exponent 1 with negative 2. So this would be 2x minus 2 plus 1, which is 2x minus 1. So I'm just rewriting it like this, and we are still subtracting 9 to the power of 2x minus 2 from this. And this is still equal to 1,944. So now, as you can see, we have two terms with 9 to the power of 2x minus 2 in them. So I'm going to factor 9 to the power of 2x minus 2 out of the left-hand side of this equation. So if I do that, 9 to the power of 2x minus 2 times 9 to the power of 1 divided by 9 to the power of 2x minus 2 is simply just 9 to the power of 1, and minus 9 to the power of 2x minus 2 divided by 9 to the power of 2x minus 2 is 1. So now, well, 9 to the power of 1 is 9, and minus 1 is 8. And I'm still multiplying this with 9 to the power of 2x minus 2. This equals, I can actually rewrite 1944 as 8 times 9 times 9 times 3. So now these two 8s would cancel out, so this would be 9 to the power of 2x minus 2 equals, well, 9 times 9 is 9 squared, times 3 is actually 9 to the power of 1/2, because 1/2 is the same thing as the square root of 9, and the square root of 9 is 3. And now, as you can see, what I've done is I've made all the terms have a base of 9. So now, when we're multiplying two exponents, let's say we have a to the power of m times a to the power of n. This is equal to a to the power of m plus n. So 9 to the power of 2 times 9 to the power of 1/2, this is 9 to the power of 2 plus 1/2. And 2 plus 1/2 is 2.5. So this would be 9 to the power of 2.5. And this is equal to 9 to the power of 2x minus 2. Now, because both are bases here, because these two are the same, our exponents are actually the same as well. This means that 2x minus 2 is equal to 2.5. And now, as you can see, we've created an equation. So now I'm going to add 2 on both sides to isolate x. So now this would get us 2x is equal to 2.5 plus 2 is 4.5. Now if I divide 2 on both sides, I get x equals 2.25. And this is our answer.